All right, good morning. Welcome to the 66th Clemson Brick Forum virtual edition. Back on the theme of education here again. Um, we're doing a very important one, something that everybody does every day. Um, it's on dye lubrication. So, why do we lubricate a dye? In soft extrusion, there was no need to lubricate a dye because everything was very fluid because you had a high moisture content. But when you get to stiff extrusion, you pretty much need to lubricate because I know that when we're running, a lot of people's running around 13.5% moisture, and you're going to have problems with dog earring, increased heat on the column if you don't lubricate. So you ask the question, uh, why lubricate a dye? Uh, One reason to lubricate a dye is for the longevity of the interior of the dye to make the interior last longer. Uh, Ease the material flow when it's coming out, so you're actually riding on the lube and not rubbing on the metal surfaces. And also, what that gives you is reduction in column temperature and internal stress. One thing you'll see if you look right down here, I got two pumps. Um, the one on the left hand side, erase this here. So the one on the left hand side here, I always set it up for the rear of the die because that's how the die is set up. Um, the one on the right hand side here is for the front of the die. Okay. Each pump head can do 7 gallons an hour. Um, that's the potential when you set the dial on 100% output. So the rear pump can do 7 gallons an hour. And the rear pump here can do 7 gallons an hour. And the front pump here, right there, can do 7 gallons an hour. All right. So when we set up the die, we set up the lubrication to where you can understand it. So we say we got the rear pump set on the left-hand side. So the rear of the die is set up on the left-hand side. So there's no question. If you notice the rear of the die there, it has 6 ports of lube. And so there it looks just like the back of the die. If you want to know which one goes to the top middle, then it's just like the die. So this is the top middle on the die where the lube goes in. And then this is the needle valve that goes to the top middle. It's that simple. If we want to know where the top left hand of the cap is, then it looks just like the die. So you got the needle valve for the top left hand side of the die. All right. Bear with me on this, trying to use all the items that are given to us to be able to do the presentation. All right. So next we'll move on. All right. What creates dial pressure on the gauges? Okay. So I asked that question because you need an understanding of what actually creates the pressure and how that changes. Okay. So if we look at the dial pressure on the gauges right here on the back gauge, you see that we're running around, looks like about 400 psi, right? So you say, why is that 400 psi? So The reason that we create pressure on the gauge is it is the resistance that the clay or shell puts, or the pressure that it puts on the lube as you're putting lube into the die. So it's the back pressure off the lube. All right, so how does that change? Well, most of the time that will change with how hard the material is, or how low your pressure is will be how soft the material is. As it gets harder, then the gauge on the needle will rise. All right. So as an operator, you're running. Let's go back here. All right, so we'll move on here. So what affects dowel pressure? We got moisture content, density of the material. When I say density of the material, I'm saying that is how compacted you get it. What affects the density? Well, we go back to what we were talking about before. Vacuum can affect the density. The particle size can affect the density. The angles of the extrusion die can affect density. All right, so also what affects the pressure on the gauge could be how worn out the die is. So if you don't have a lubrication lip in the die, there's nowhere to carry the lubrication, and all it does is penetrate the material as it's extruded. Also the condition of the pump. I've went in plants and had problems getting pressure from the pump, and find out that maybe the gear oil is low in the gearbox, which the pump is using that to create a seal to maintain its prime in the pump. Also, things that can affect the pressure, obviously, is the amount of void. When you increase the void and you have more void space, then you have less surface area for the brick to exit the die, and you get more back pressure, which creates more pressure on your gauge. And then also you go back to the size of the brick. If you're running a profile that's, say it's a Monarch, say it's a 16-inch brick, then it's easier to come out of the die because you have less taper in the die, because most augers you go into plants, they're 18 inches. So you create less back pressure because that material's leaving the die and it hasn't been formed as long. Next thing is bridge configuration. Are you running a single bar bridge? Are you running a double bar bridge? Are you running a vertical bridge setup? Maybe it's a split tile and you got a vertical bridge set up. So how much back pressure are you causing with the bridge? I see a lot of times people want bridges to last longer and last longer, and somebody's made a larger bridge, a thicker bridge bar, or put a bunch of hard surface weld on the bridge, and then what that does is it creates more back pressure. The material can't flow out of the die as easy, and then you end up creating more pressure in the die because it's harder to exit the die. And we know that once you create more and more back pressure, that you're either, if you got a hinge door, you're going to blow the shear pin. Maybe if you don't have a hinge door and you got a slider, maybe it'll be bad enough that you're going to stall the motor, trip out a VFD, and then that high dowel pressure is just related to the material not exiting the die very well. You see a video here, you see the dowel pressure. This is from the profile that some of y'all might be familiar running. It's got different names. Some companies call it an XL, some people call it a Max. This product basically a little over a 10-inch brick, and this one happens to be on a double bar bridge. All right, so when we look at this, we saw that the pressure, the dial pressure, was around almost 600 psi. They're running a double bar bridge. They have a void of 25%. They're also running scoring on this brick, and which creates resistance, a little bit of holdback. So we see a little bit higher pressure running that product. They also have a pretty hard shell, and they're running a very low moisture content. They're running as low as 13% on the moisture. So there we see moisture content affects dial pressure. They grind fairly fine. The material breaks down and grinds pretty fine. So it's a very dense extruded material. The condition of that die was good. It was a new die. Matter of fact, we just put that one on and started running that day, so it needed a little break-in time probably. The pump was in fairly good condition. The percentage of void is not the highest, but it's on up there. It's pretty high. And then the size of the brick, a little bit larger profile, but it's got a fairly low bed depth. And then we already discussed the core configuration, which was a double bar bridge with 2 lines of cores, and it is actually a 10-hole bridge. All right, so we'll look at another scenario here. I'll run a short video, but this is actually a refractory, and this product, when it's extruded, is almost 13 inches long. It's a car top block, a 2-cell car top block, and it's run on an old Bono extruder. They're not running very fast. They're they're just making refractory. They're not concerned with a whole lot of speed. They're just concerned with dimensional control and good quality product. And they are running on a little bit of a higher moisture content. I would say we were running these around 17.5, 18, because they're limited on their cutter afterwards. They're cutting with a wire, and it's a Frymatic cutter, so they can't get it too hard. And obviously we'll see here that the percentage of void affects the product, because the void here, and it affects the dial pressure, but the void here is only around 19%. And the size of the brick will affect what we see on the gauge, and then also the extrusion speed. We're just not running a whole lot of volume of lube on this because the machine runs so slow. I'll run this video here. You'll see we're a little below 200. You see how slow material extrudes. It's a pretty large profile product, about 4 inches in bed depth. It's just a 3-cell block. And it's got a lot of room to exit the die, not much restriction there. One more time. All right, so this is the configuration here on that product that we just seen extrude. As you can see, when you do it by surface area, they're about 19.5% void on this product. And we're running so slow, we don't have the volume turned up on the pump very high because we're extruding so slow. And then also, you got a very large surface area for the product to exit the die. All right, what do we need from a brick die lubrication pump? We need consistent pressure and volume at a low rate. If you think about it, what we're asking these pumps to do, and what I mean, it's a very low flow rate, but what we're asking these pumps to do is we have two pumps here. We got the rear pump right here. That pump can pump 7 gallons an hour at 100%. Most cases I see out in the field, you can pretty much say that they're going to run this rear pump from 30% down to about 20%. That works in most typical brick manufacturing. So you're probably looking at pumping maybe 1.25 gallons to 1.5 gallons an hour on that pump right there, and it's delivering to 6 ports during that time. So it's a very small amount of lube that you're running through that pump. And then when you go to the front pump, when you look at the front pump, which is right here, you got the same scenario. That pump will pump 7 gallons an hour. Typically that pump will be set on around 10 to 15% of its full capacity. So you're only pumping anywhere from 3/4 to a gallon of lube an hour. And that's going out to 4 ports if you got a typical setup, say you're running modular to king size brick. So you're not really pumping a whole lot of lube when you're pumping. All right. You also need independent control of both front and rear. That way, when you're lubricating the rear of the die, you're getting that first coat on there, and you're getting enough lube to carry it up to the cap, where you're going to have 4 ports, and you're going to use the second pump, the front pump. Again, we'll go to that, but that's the front pump right there. So you're going to use the front pump pumping to 4 ports. And what you're wanting to do, you're wanting to put enough on that rear pump just to get up to the cap, and then let the front pump finish out the corners and make nice corners for you. All right, and then you want to pump this easy to control, and I'm going to go over that later on in the presentation, but you want to pump this easy to control. You want to pump this Brickyard Tough, and that will run every day, all day. And then you also want to pump that, you want the pump to come on with the extruder clutch, and then when the extruder clutch disengages, you want the pump to turn off. I've been where there was setups where people had a manual lube pump, and the operator has a lot to do, and then he's going to forget about it, and then you're going to flood the die because you're not going to turn the pump off. But most will have a pump that comes on and off with the clutch. But I just mentioned that because I have run into situations where it doesn't. You also want a pump that will pump oil-based or water-based lube. Why do I say that? The reason that we came up with a water-based lube or a high concentrated soap that you can dilute with water, the reason that we came up with that is because we had customers that were running glazes and some slurries and slips that wouldn't stick to the column when they had oil on them. So once you run water-based lube or soap, then you don't have that problem, because as soon as the brick exits the die, it pretty much is dry because it hits the air and the soap dries out on the column. So that's why a lot of times that people will run a water-based lube or concentrated soap, which ours is called RP3, Reymond Products 3, and that gives them the ability to run glazes and stuff and retain them on the column. One thing that we found out was that when this was developed, that it was also cheaper, because in most cases our customers can run 30 to 1. So you got 1 part soap, 30 parts water. So it becomes very cost effective, where people are typically running a oil-based lube they're paying anywhere from $6.50 to $7 a gallon, where when you calculate and do your RP3 on a 30-to-1 ratio, you're looking at around 85 cents a gallon. So you can see why that's pretty cost effective. We again will go back to a multi-pump lubrication. Yes, if you were running a small profile product and you only had 4 ports of lube, then you might only need 1 pump. But typically when we're making brick in the United States or Australia or the UK, you're running a product that needs more lube than that because it's a larger profile product. So we use a dual pump. So what we'll do is, again, we'll drive this home. We'll take this rear pump, and it will be pumping for the rear of the die. That's the rear manifold right there. It has 10 ports of lube. All right. And then this pump right here will be set up for the front. And the front manifold is right here on the right side, just using the right side pump. Okay. So that makes it very direct and simple. All right. So that allows you to have superior control of both the rear and the front, and you can pinpoint the volume that you need on the rear, and you can pinpoint and pressure, and then the volume and pressure on the front, because they're independent pumps. You're not having to use a regulator to split the two. And this becomes necessary in plants that are running a high production or extruding fast. I go into some plants that are running 45,000 brick an hour these days. Very fast extrusion line. So they need a little more volume, and they need a pump that'll deliver that volume and pressure on a consistent basis. We find out and have been using the Neptune pump for a long time, which is a chemical dosing pump. And the reason it's very effective in the brick industry is that it is delivering a low volume of lube and maintaining a pressure that is needed to run that, a higher pressure. All right, not too high, but a higher pressure. All right, high enough for the moisture content that you're running. So obviously, if you're running a lower, a high moisture content, say if we're not stiff extruding, say we're running up around 20% moisture, then we could actually turn the pressure down on the pump to a maximum level that you could achieve, and then if you're running on a stiff extrusion, then we could turn that pressure up to what the pressure that you're gonna, a little above the pressure you're gonna create in the die. And the reason I say that is if you wanted a little above the pressure you're gonna create in the die, then you won't be clogging your lubrication ports up. All right, so when you first get a die from Reymond, we have lips at the mating surfaces. Okay, so the first place that we introduce lube into the die is on the rear of the die, and you see that back here at this lip right here. All right, so when you enter the die, you have the exit opening of that adapter ring there will be an 1/8 inch smaller than the entrance opening of the bridge ring. So we have the adapter ring right here, and then we have The bridge ring is this portion right here. All right. So we set it up to where the exit opening of the adapter ring is an 1/8 inch smaller than the entrance opening of the bridge ring. And what that does is it gives you a place or a reservoir to carry the lube, and so the material is running over the lube, and and it helps it flow on the interior of the die because the material is running over the lube and carrying the lube through the die. All right. So that's the first place we lube. And then the next place we lube is between the center section and the entrance of the cap right here. All right. So what you got there is you've got another 1/8 inch lip, and that actually helps you come through the die. You have a reservoir to carry the lube there, and then as the material flows over that, it pulls the lube through the die. All right. So that is how we carry the lube through the die. What that does for you, it requires less lube to do the work because it has a place to carry it. And without the lips, then you'd be penetrating into the column, which we all know that we don't want oil or lubrication inside the column because that can cause lamination in the product. All right. So we'll go over something right here. So every die that has a bridge in it or holds cores has a bridge bar right here. All right. So when you flow over that bridge, the material is separated, right? And then as you exit the die, that's when you have to knit that back together. All right. So we ran over the bridge bar, and then we're exiting the die. So after we go over the bridge bar, we have this much area that we got to knit that back. That much area that we got to knit that back before it exits the die, so that you don't have a lamination from coming over the bridge. All right. So you don't want to over lubricate the rear of the die, because when you over lubricate the rear of the die, then when you come over the bridge bar, if you over lubricate the rear of the die, then you get oil back here on the bridge bar, and you can't seal it back together before it exits the die. All right. So again, we'll go back to it's the amount of lubrication ports are dictated by the size of the product, how big the product is, the void area, the shape of the product, and the length of the die. So a general rule of thumb, the larger the product or longer, then you're going to have more lubrication ports to cover that area to make sure that you are able to lube the whole product when it's exiting. All right. Using die lube. All right. Die lube, I don't try to tell people what to use. I ask them what makes them happy or what they're going to be happy with on lubrication, because some people want to use oil-based lubes, and some people have products that oil-based lubes cause a problem. So if you have that where you're running glazes and slurries that don't want to stick to a column, say you're running them on smooth columns and they don't want to stick to the column because of the parting line of the lubrication, then we have the alternative for you of RP3. One thing RP3 does is it allows that glaze to stick. It allows those slurries to stick on a smooth column. And in today's world, environmentally, people don't want lubes running into the storm water and things like that. So I actually have customers out in California that run RP3 because the EPA won't let them um, run oil anymore on the column. So or diesel fuel. So they're running RP3 for an environmental um, concern. Also, if you're running RP3, it reduces your fire hazard. And I know y'all, all the brick manufacturers have insurance carriers that come and look at your operation, look at your plant. And I know that fire hazards are always a big deal to insurance companies. So it's also helps you with insurance concerns, and then also it can save you money. And from an extrusion standpoint, when you're running, if you're using lubrication and say you're using oil, then and you're paying $6.50, $7 a gallon, and you change over to soap and you're paying 80 cents a gallon with this RP3, then you're automatically saving money as soon as you turn the extruder on. Also, you're less likely to cause a lamination from a bridge crack with soap than you are than running an oil-based lube. You can do it with soap. I'm not going to say you can't. If you got really crazy, you could do it with soap, but you're less likely to do it with soap. All right, so I'm going to show you a few things here. Dilube and how much to use. I'll show you. I haven't made this up. People were running product just like I'm going to show you in the video. You obviously want to use enough pressure and enough volume of lube so that the column is lubricated when it exits the die, but you don't want to be putting lube all down through the process. And what I say by that, I've seen people turn up the lube at the die just so they could have some oil on the bottom to go down the texturing line, or to lube a belt in front of a wire bank and a slug pusher or something like that. And you don't want to cause an issue with the product by over lubricating the die. If you need, what I would say is, if you need lube in a downstream process, then put it down there. Don't over lubricate the die to get it. So I'll run this video here and you'll see an example of what not to do. As you can see right there, I'll run it again. If you look in the bottom left corner, you're spraying oil out on the camera. And we're obviously over lubricating the die there. All right, so what is the effect of too much oil pressure? We can see right here that they are just penetrating by having too much oil pressure. So they're penetrating and blowing holes in the product. This wasn't a situation where, this was on startup or anything like that. They were actually running brick like this. All right, so we don't want to do that, okay? So when you see this blowing the corners out, that's obviously way too much lube. And on our setup, because we lube in the rear and the front, what you would do there, that's down here in this corner like it is, then you would have had too much pressure on the front of the die, and you could turn the front down. I'll show you another one here. We'll talk about what we got in this picture. But when you look at this, that's actually up in the column. So if you were on running our product, our die, then you could only do that at the rear of the die. You couldn't do that at the front of the die. You could do the corners. You could do the corners at the front of the die, but you wouldn't be able to do the right way up there in the middle. So you could do right down here in the corner at the front of the die. All right, so you got an example of what not to do. So this is how you want the product to look when it comes out. You want it to have enough dye lube to exit the dye, but not put lube all over the rest of the process. You want it enough to exit the dye, but not lube the rest of the process. And so I'll run this little short video here, and you'll see that. So as you can see, we're not penetrating. We got enough lube here that we're not going to penetrate the column, and the lube is staying on the outside. Right. So I'll show you a picture here of a nice smooth column with no penetration. You can see you got a nice smooth column, good corners, no penetration. This is what you want. You got enough to lube the dye, but not the rest of the process. All right, so you say, how do I know that I'm over lubricating? Well, I showed you on the front where if you're getting corner penetration, it's easy to see that you're getting a wet check. So you got a penetration on the side that you got lube running out of. But here's a test to show you how to check for if you've got too much on the rear of the dye and you have a bridge crack. So I'll run this video right quick. So you want to cut the heads off here. Then you're going to hold it in your hand. You're going to put equal pressure and break it. And when it breaks on a crooked line like that, not a straight line, then you know that you don't have oil penetration. If you have oil penetration, we'll watch that again. If you had oil penetration, then you would have a smooth surface on the inside. You can see where the oil is penetrating, not getting back when it comes over the bridge, and it break a very straight line and break easy.
That'll work.
So that gives you a tool to check whether you're doing too much. If you got a case where you've got penetration back there, then you've got too much pressure on the rear of the die. All right, so let's talk about pump adjustments. So on our pump, you have graduations here. And these graduations go from 10% to 100%. All right. So if you turn the knob clockwise, so you're screwing it in, then you're increasing the flow rate, and the pressure. All right, so if you turn it in, then you're increasing the flow rate. So you have this knob here, and you've got one for the rear pump, independent control on the rear pump head. And then you got independent control for the front pump head. And I'll show you this video right quick.
There it is, clockwise. 20%, 21, 22, 23, 24.
All right, I'm gonna run it one more time.
10%.
So you got one full turn around.
There it is, clockwise.
10%.
20%, 21, 22, 23, 24.
All right, so then you got individual control, and you can go a full 10% on the rounds, and then you can go by 1%. So you got these numbers right here, 1 through 9, and that will give you another 1%. So once you get it dialed in, say you're on 20 and you want just a little bit more lube, then you can do them by 1%, and that's what I showed you on the video. Those 1% increments going up. So I'm going to run that one more time. And remember, I'm going to be available for questions at any time. So
10%. Here it is clockwise. 20%. 21, 22, 23, 24. 10%. It is clockwise, 20%, 21, 22, 23, 24.
So if you've got any questions, like I said, I'll be available the whole time during the virtual forum. And then also, if you want to email us or anything like that, all our email contacts are right here on the presentation. Again, I appreciate your time. And I hope everybody stays tuned in to the 66th Clemson Brick Forum Virtual Edition. Thank you very much.